All right, everybody, I'm ready to get started. Welcome back, everybody. Welcome back to the third week of this course, the third of roughly 16 weeks. So we're moving right along. I hope everybody's doing well. I hope you had a good week. I hope, most importantly, you are in this. Like, you are in school. Your mind is in this. This is your priority. This is what you do. You might have some extra time. If you do, enjoy your life. But if you don't, it's fine because you signed up for this, and this will end, when summer comes around, which will be here before you know it. But up until that point, it's all about working extremely hard, and that is all this is about, and that is all this should ever be about. Um, so, I hope your level of dedication is where it needs to be right now, and if it is not, it needs to be there immediately. Things are happening. Things are moving forward. Today we're going to cover chapter 3. We've covered chapters 1 and 2. Next week we'll cover chapter 4, and then the week after that, first exam. So 4 chapters covered. First exam covers those 4 chapters. So it's coming. It's not here yet. We're halfway there from the time we started, but because, we only meet once a week, like, we only have one more meeting after this before the first exam. So, things are happening, important things are happening, and you should be all in. You should be thinking, okay, I've got this much time ahead of me. This I know is coming up. These are other things that are happening in my life. These are other things happening in my classes. Make a plan for yourself. I'm going to need this time over here to work on these other classes. Then I'm going to need to dedicate this amount of time to reviewing what I've already covered in this class, plus learning the new material before the exam so I can do really well in the exam. So it's all about like foresight. It's all about thinking ahead, making sure that that you don't get backed into a corner, and you just wind up in those situations where you just do not have enough time to do the things that you know you should be doing so that you can have the kind of performance you can have, and ultimately be able to demonstrate that to others that aren't clearly able to see that. Like, others that you are trying to impress. I'm not necessarily one of those people, but eventually when you get out into the world, you're going to want to have a track record that's strong, that you can say, hey, look, I'm worth your time. I'm worth the opportunities you have. So you want to be able to demonstrate what you already know you have inside of you to other people, to show them that yes, there is value in you, and it is worth their time to pay attention to you, and that is built up through like just minor, large successes throughout college, right? So large success in an exam not too big, a minor large success, but as they accumulate over time, there's a clear record of success, clear record of putting in big amounts of effort that is highly valued in this world. When people are dedicated and working extremely hard, that's what people are looking for out there. So if you can demonstrate you can do that here, then you'll be able to demonstrate outside. And that demonstration is not necessarily just about showing other people what you can do, but also showing yourself. Because even though you know that you can be great, there's times where you might actually put up your own limitations to what you think you can do based on what you've done in the past, and really not acknowledge the things that you can do that you may not even know you can do. And the only way you can get there is by pushing yourself harder than you think you can push yourself, working harder, longer hours, whatever, than you are normally comfortable with. So all of that effort, all of that sort of propensity, drive to demonstrate should be ultimately what is driving you to do well in this class. It's all about like small, big successes that get you to the big successes out there sometime in your future, which is coming, which will come. This will all work out for you. This is not all a bunch of crap. This is not all like silly whatever that you're just forced to do. This is like, it's worth your time. This is actually going to get you somewhere. So put everything you have into it every single moment, and things will work out, at the very least in this class. And in the long run, it definitely in your lives. All right. So, is there anything you'd like me to address before I jump into the material for the day? We will cover all of chapter 3 today in our 2 sections that we have in one day. All right. Just a reminder. The deadline to register for Piazza is Sunday night. If you don't register for Piazza by Sunday night, you will lose half your communication grid. So make sure you do that. It takes 2 minutes. Assignments. Everything that's been assigned is due in the middle of next week. Ideally, you have been doing them though. If you chose to do mini papers for the chapters we covered, hopefully those are already done. Homeworks ideally are already done. And if they're not, get on top of it. Get that done. I'll open up chapter 3's homework tomorrow when I get all this stuff uploaded for you guys. Make sure you get that done as well. And if you can, jump forward to chapter 4, cover that. It's a more abstract chapter as far as like the concepts. Like the model is not necessarily, unless you briefly covered it in your micro course, which I do in my micro course. I don't know if you did in your micro courses. Unless you covered that model, which is the rational consumer choice model with budget constraints and indifference curves. If you haven't covered that model before, it's challenging. You know, it's like something you haven't seen before. It's not necessarily intuitive. So it's going to take some time for you to get it down. And so you might want to start on that now versus leaving it till next week where, you know, you're going to have to try to learn the new material on top of reviewing the old material, on top of getting your homework done, etc. So my advice to you is to get ahead. I'll open up chapter 4's homework as well. So those will just be open for you to do, so you can get to work on that as well. And again, of course, I'll cover all of chapter 4 next Tuesday very clearly, but I've also recorded these lectures before, so they are on my YouTube channel, on playlist. You can use that. Again, everything I offer you is a resource. It's not meant to be used in a particular way. It's meant to just be available to you so that you can decide what approach you want to take to succeeding in this course. So the more resources I have available, the more flexibility it gives you, and that's ultimately what it's meant for. It's meant for you to use them to use your time as efficiently as possible. So again, you have right now 2 weeks before the first exam. Use that time wisely. Other stuff is probably going to start hitting you from other classes as well. Things in life, you never know what life will throw you. So, you know, again, opportunities are times when things aren't pressing, when you don't have 1,000 things piling up on you. So this is a major opportunity for you. Take advantage of it. Do the right thing for yourself. Make this work out. Don't make this a painful process. It'll be so much better for everybody, including me, because I want to see you all succeed. But in the end, like, it's you who has to succeed. Like, I cannot do it for you. So do it. Do the right thing. Show me that you can. Show me that you are great as I know you are. Demonstrate it to me. It would make me happy, and it would make you even happier. So that's what's coming. You should be thinking about it. I hope you have been. If you haven't been, start thinking about it. And now we're just going to jump into today's material. So last week we covered essentially what's called qualitative demand analysis. We looked at the demand curve. We looked at the supply curve. We looked at how that establishes an equilibrium for markets. We looked at the various things that can affect either side of the market, shifting the curves, changing the equilibriums of the market, which led us to do comparative statics, comparing one static equilibrium to another when things changed. But all of it was very sort of descriptive. And so this chapter is more about like taking at least on the demand side, like the concepts from the demand side and making them a little bit more accessible and practical. So first I'll establish some important measures that one can use by analyzing demand. You've at some point in the past been introduced to the concept of elasticity. Elasticity is not a concept particular to economics, even though it is defined within the field. But the general concept itself is just how sensitive one variable is to changes in another variable. We generally talk about The price elasticity of demand, which is the first one we'll cover, telling us how sensitive is quantity demanded to changes in price. When prices change by $1, does quantity demanded change by more than 1 unit, less than a unit? Is it very sensitive to price changes? Is it not sensitive to price changes at all? And then we'll just keep going from there, kind of applying this general elasticity concept to the cross-price elasticity of demand, how sensitive quantity demanded is to changes in prices of related goods. We talked about related goods last time. So they can either be complements or substitutes, right? Complements, goods are bought together. Substitutes, they're bought in place of each other. As the price of one goes up, people buy more of the other. People substitute away from the more expensive one to the least expensive one. So we'll just look at the measure of cross-price elasticity of demand, and then we'll look at income elasticity of demand, how sensitive changes in income, how sensitive are changes in quantity demanded to changes in income in a market. And again, there is that relationship between the good and income. Either it's a normal good, as income goes up, people buy more, or it's an inferior good, as incomes go down, people buy less. So those are some of the important sort of concepts that we can derive from the demand relationship that we studied last time. And then we'll talk about how do we obtain measures of elasticity from actual data. So like if you were to get data on your market that you're interested in selling in, you can extract these elasticity values that'll tell you how sensitive quantity demanded is to these various variables. And so we'll talk specifically about the statistical method used to extract these important numbers from data, like real world data. And so it'll be a brief review of like some statistics stuff. I don't know if you've taken, I know all of you have taken statistics, but you may not have taken econometrics, which is like sort of like the economics field kind of taking statistics for itself and kind of moving it forward in its own way. It's a pretty cool area. It's very technical, and there'll be some technical sort of discussion of like the statistics that are used to measure how well we're estimating these things based on the data we're looking at, like how much predictive power that can give us for these actual relationships from maybe like a small data that we might have about a market. But I won't get too much into it, but I will mention some of these things via the analysis, via the regression analysis, which is the main approach used to estimate like the relationships that we use in economics. Either you've heard of regression analysis via your statistics class or you haven't, it's all right. I'll cover it today. I'll cover what it means. I'll cover what it does. Not too specific. I won't actually show you how to do it. I'll mention how to do it, but I won't show you how to do it. I won't expect you to be able to do it. But you should understand it. Like you should get it. And that's what the point of this is, just to kind of make you aware of the fact that, via a quantitative demand analysis, you can do a lot of analysis on your market and learn a lot of information about the good you may be selling in your market with like very minimal means, not necessarily needing like an economic consulting firm to help you or, like an economic analysis department. These are like simple things that even like small businesses could do and gain insights from. So that's basically what we're going to cover today in chapter 3. We'll cover half of it, take a break, cover the other half. We'll stop before the this part here. This will be the second part of the course, for today. Alrighty, let's go forward with chapter 3. So again, we're going to apply various elasticities of demand as a quantitative tool to forecast changes in revenues and prices and or units sold. So there's a very important relationship between the own price elasticity of demand, how sensitive quantity demanded is to changes in price, and revenues that can be gained in a market. So we'll talk very explicitly about that relationship. We'll illustrate the relationship between the elasticity of demand and total revenues. We'll discuss 3 factors that influence whether the demand for a given product is relatively elastic or inelastic, what What determines how elastic demand is? We'll talk about that. Explain the relationship between marginal revenue and the own price elasticity of demand. Marginal revenue is the extra benefit you gain from selling an additional unit. It's the extra revenue you gain from selling an additional unit. It is the marginal benefit of a firm that's selling. It's their marginal revenue. We'll talk about that, the relationship to own price elasticity of demand, and how that can be useful to understand. We'll show how to determine elasticities from linear and log linear demand functions. So I'll mention just a quick review of logarithms, just so you can understand the relationship between the normal demand function and the log linear demand function, which can be used to extract elasticities from a regression analysis. We'll explain how regression analysis may be used to estimate demand functions and how to interpret and use the output of a regression. So as is always the case, my lecture is the main source of information for the course, so you'll see more detailed stuff in the chapter, and it will cover some things that I didn't cover. Again, only the things I cover in my lecture are going to be fair game for the exam, so anything you read in the book is just meant to, expand your knowledge of everything we're doing, and even just your understanding of the things that I have covered versus those that I have not. All right, anyway, so in chapter 2, last week, we saw that the demand for a firm's product that we can denote by the quantity demanded, that's what the D stands for, and the X denotes the fact that it's the quantity demanded of some good X. Depends on its own price, right? So the price of good X is denoted P subscript X. Also, the quantity demanded of good X can be dependent on the price of substitutes or complements. So some related good, let's call that good Y. And so then the price, the P subscript Y denotes the price of the related good versus the P subscript X, which denotes the price of the own good, the good we're talking about. Also, quantity demanded of good X is affected by income, right? Which we denote in economics generally with an M. So the M variable here represents incomes in the market that's being studied. And then finally, we have H. H can represent advertising. It can represent the size of a population. It can represent consumer expectations, other things that affect demand, quantity demanded. So we know that functionally we can relate these variables via this very general functional relationship. This is basically telling us that the quantity demanded of good X is a function of these variables. We don't know what kind of function it is, if it's a linear function, if it's a quadratic function, a cubic function, logarithmic function, we don't know. We're just saying that this variable is affected by these variables. So this is the dependent variable. These are the independent variables. So that analysis of the impact of changes in prices and income on consumer demand has been qualitative rather than quantitative. We've just been describing the relationship, the magnitudes, what they mean in terms of like either if we're talking about normal goods, inferior goods, substitutes, complements. So a successful manager is adept in providing detailed quantitative answers to answer questions like, how much do we have to cut our price to achieve maybe a 3.2% growth in sales? If we cut prices by 6.5%, how many more units will we sell? Do we have sufficient inventories on hand to accommodate the increase in sales? If not, do we have enough personnel to increase production? How much will our revenues and cash flows change as a result of a price cut? So again, like everything that's being presented here has very practical applications, and even though you may not personally use the information, you need to be aware of the fact that there's people using it, and they can help you to, maybe manage your business better, manage your firm better, whatever level you wind up with. So essentially, what this is saying is that the first half of the chapter is going to sort of highlight just the general nature of these concepts. It can be useful to answer some of those questions, the elasticity concepts. And then the second half of the chapter describes the regression analysis, the actual practical means of getting this data from your market, going from the real world to what you need in order to do your analysis and have your firm function as best possible. Profitable, ultimately, is what we're looking for here. We're looking for profits. All right, so let's talk generally about the elasticity concept. Suppose some variable, let's say the price of a product, increases by 10%. The question is, what would happen to the quantity demanded of that good? So based on the analysis in Chapter 2 and the law of demand, meaning that as price goes up, quantity demanded goes down, and vice versa, they're inversely related, right? They move in opposite directions, quantity demanded and price. We know that quantity demanded would fall if the price were to go up by 10%. It would be useful, though, for a manager to know whether the quantity demanded would fall by 5%, 10%, or some other amount. So the primary tool used to determine the magnitude of such a change is elasticity analysis. Elasticity is a measure of the responsiveness of one variable to changes in another variable. It's the percent change in one variable that arises due to a given percent change in another variable. So again, it's a very general concept. It doesn't necessarily have to be applied to economics. So let's say, for example, the elasticity of your grade with respect to how much you study is denoted E subscript G, comma S. So elasticity of your grade with respect to S is what this notation is telling us. So that is the percent change in your grade, percent change in your grade. So the triangle in mathematics represents change. So that's what that symbol is telling us. A percent change in your grade that will result from a given percent change in the time you spent studying. So the percent change triangle in the amount you spent studying, S. So the elasticity of your grade with respect to the amount you study is equal to the ratio of the percent change in your grade with respect to the percent change in how much you study. Now, the percent change in your grade is equal to the change in your grade with respect to where the grade initially started from. So in your introductory micro course, they talked about the midpoint method and how that's used to calculate elasticities. We're not going to think about that here because we're not actually going to use this expression, the expression that requires us to look at the percentages. We're going to derive another expression that we can then use extract information from our regression analysis to provide us the insights we need without having to think about, like, are we starting at a price or are we ending at a price? Like, don't worry about that. Just think about this very generally in mathematical terms. There's a change in your grade with respect to where the grade was. And then you multiply that times 100, and then that gets you a percent change in your grade. The percent change in the amount you study, same thing. You've got a change in the amount you study over the amount that you're studying, some starting point times 100. So we know that the elasticity of your grade with respect to studying is the ratio of these two. So we plug these expressions in. We get this ratio here. The hundreds cancel out. And then you're left with this expression here. The change in your grade with respect to the initial grade over the change in your studying divided by the amount you initially were studying. Simple property of ratios. When you're dividing a ratio by a ratio, that's equivalent to the top ratio times the reciprocal of the bottom ratio. So this is equivalent to this top ratio times the reciprocal of the bottom ratio. So the change in G over G times S over the change in S. Via the commutative property of multiplication that says that you can just move things around that are being multiplied, we can move some of these things around and get to this expression. The change in G over the change in S times the amount of initial studying over the amount of the grade is another way to express the elasticity of your grade with respect to studying. So we've derived this expression. This term here in calculus, if you remember, can be approximated by the derivative or the slope of a curve, which we can write, which then allows us to write the elasticity equation as so the elasticity of your grade with respect to S equals the slope of this curve that relates the grade to how much you study. So the grade is the dependent variable, how much you study is the independent variable. So this is the slope of that curve times the amount you study over your grade. So that's another way to express the elasticity. And it's going to be useful moving forward in what we're going to be doing. All right, so two aspects of an elasticity are important. One is whether or not it's positive or negative. The sign of the elasticity determines the relationship, in this case, between the grade and the amount of studying. If the elasticity is positive, an increase in your grade leads to an increase in, an increase in your studying leads to an increase in your grade. If the elasticity is negative, an increase in your studying leads to a decrease in your grade. And then the other thing that's important is the magnitude of the elasticity, whether it is greater than 1 or less than 1 in absolute value. So remember, absolute value is the distance of a number from 0 on a number line, right? So if you have like negative 38, absolute value is 38. It's 38 units from 0. If you have 0.75, the absolute value is 0.75, which is equivalent to the absolute value of negative 0.75. They're both the same distance from 0, right? Absolute value. All right, so whether the absolute value of the elasticity is greater or less than 1 determines how responsive G is to changes in S. If the absolute value of the elasticity is greater than 1, then we know that a small percent change in S, in the amount you study, will lead to a relatively large percent change in your grade. So your grade is very responsive to changes in the amount you study. Versus if the absolute value of the elasticity is less than 1, it's between 0 and 1 in absolute value. In that case, a given percent change in the amount you study will lead to a small, relatively small percent change in your overall grade. All right, so that's just sort of like the general mechanics of elasticity. Now let's jump into the actual elasticities that are relevant to you in this class. Starting with the one that's most important, the own price elasticity of demand, also known as just the price elasticity of demand. It's one that you covered in your microeconomics course. So the own price elasticity of demand is a measure of the responsiveness of the quantity demanded of a good to a change in the price of that good. It's the percent change in quantity demanded divided by the percent change in the price of the good. So for a demand function, like this general functional relationship we have here, the own price elasticity of demand is denoted by this expression here, where we have the elasticity of the quantity demanded of good X with respect to how much its own price is changing, the price of X. So it's the percent change in quantity demanded of X over the percent change in the price of X. And we know, based on the derivation I just did, that this is equivalent to the sort of the estimate of the demand function slope times the price and quantity at the point that we're interested in studying. So remember, this is an estimate of the slope of the demand function, and we're talking about a demand function because its quantity is a function of price versus price as a function of quantity. That is an inverse demand function. All right, so that's the own price elasticity of demand, and this is how we can express it. If the own price elasticity of demand for a product, let's say, is -2, then we know that a 10% increase in the price will lead to a 20% decline in the quantity demanded of the good. Since -20% over 10% equals -2. By the law of demand, there is an inverse relationship between price and quantity demanded. Thus, the own price elasticity of demand is always a negative number. So no matter what, because we know that there is that inverse relationship, this measure will always be negative. But of course, the magnitude needs to be described depending on whether it's between 0 and 1 in absolute value or greater than 1 in absolute value. So demand is said to be elastic if the absolute value of the own price elasticity is greater than 1. So right there. The bars, again, represent absolute value. demand is said to be inelastic if the absolute value of the own price elasticity is less than 1. So between 0 and 1 in absolute value. Remember, we're always going to be talking about a negative value with own price elasticity of demand. So you're always going to need to think about it in absolute terms to be able to define it in these ways, either elastic or inelastic. Or finally, if demand is said to be unitary or unit elastic if the absolute value of the own price elasticity is equal to 1 exactly. All right, let's talk about the relationship between elasticity and the total revenues that a firm can earn in a market. So here we've got a table. It has the there's a demand represented by this demand function, QD of x equals 80 minus 2px. And here we have a demand schedule, just representing basically increasing prices and decreasing respective quantity demanded at each price. Here we have the own price elasticity of demand that we see is changing along the demand schedule, which is also along the demand curve. And then we see the total revenue is also changing as we move along the demand curve. So notice that the absolute value of the own price elasticity gets larger as price increases. So at low levels of price, we see that the own price elasticity is between 0 and 1 up until a price of 20. And thus demand is inelastic when price is low, right? When price is low, changes in price don't lead to huge changes in quantity demanded. So quantity demanded is not very responsive to changes in price when price is low. But when price gets higher, beyond line E, where the elasticity is equal to -1, which is 1 in absolute value, unit elastic. Beyond that point, we see that demand gets very elastic, and that corresponds to the high prices in the market. So when prices are high in the market, generally you're going to have more elastic demand. Elastic demand, just describing what we're seeing here. It's greater than 1 in absolute value. So the slope of this linear demand function we know is equal to -2, which is constant. That is not changing. So if we look at our expression for the elasticity that we derived, we know that this part is not changing at all. That's constant. And so what this is telling us then is that our elasticity is increasing in absolute value as the price of x increases. So as this goes up, this is increasing. This is staying constant. And that's where you're getting that increase in elasticity from as the price increases. But that's not the end of the story here. So the own price elasticity of demand varies along a linear demand curve is sort of just a general characteristic of demand. So you're going to have varying elasticities along the demand curve. And that's going to mean something for total revenue. So when the absolute value of the own price elasticity is less than 1, so we are along this range here when prices are low, an increase in price will increase total revenue. So let's say you're a firm, you want to increase your price from $5 to $10. Demand is inelastic, so you know that revenues are going to increase as a result of you increasing your price. When the absolute value of the own price elasticity is greater than 1, so we have high prices, an increase in price will actually lead to a reduction in total revenue. So increasing price along the elastic range of demand will lead to a decrease in total revenues, going from 750 to 600 to 350 to 0 there. Since total revenue was increasing and now it's decreasing, there's got to be a point at which it's at its maximum, right? It happens to be the point where demand is unit elastic. So unit elastic corresponds to the point where total revenues are at their maximum. So this relationship among the changes in price, elasticity, and total revenue is called the total revenue test. So here is a demand. In this case, it's just general. We're not talking about any good in particular. So what the total revenue test tells us, that if demand is elastic and there is an increase in price, it will lead to a decrease in total revenue. And also it tells us that if demand is elastic, a decrease in price will lead to an increase in total revenue. So let's say we're starting, so this is the elastic portion of the demand curve, again, corresponding to the high prices, which correspond to low quantity demand. So if the price, let's say, goes from $9 to $8, you're lowering your price. Demand is elastic. When demand is elastic and price is being lowered, total revenues increase. But let's say you're going from 2 to 1 unit. So in that case, you're raising price. If you're raising the price, then total revenues will decrease, in this case, from 2 to 1. So down here, we have total revenue as a function of quantity. And we see that it is decreasing from left to right as we are moving from left to right on here, which means that we are increasing prices. So again, increasing prices decreases total revenue, and decreasing prices increases total revenue when demand is elastic. What the total revenue test also tells us is that if demand is inelastic, so this range just popped up, if demand is inelastic, an increase in price will lead to an increase in total revenue, and a decrease in price will lead to a decrease in total revenue. So again, let's say we're at this point here, and we want to decrease our price, so quantity demanded will increase. You decrease your price over the inelastic range, and that leads to a decrease in total revenue. And it works the opposite direction. If you increase your price, that increases total revenue over the inelastic range of demand, again, meaning that elasticity is between 0 and 1 in absolute value over that range. And then, of course, what it also tells us is that total revenue is maximized at the point where demand is unit elastic. And so here we see that is the peak of our total revenue curve. That can be mapped out from the top edges of all of these bars. All right, so businesses around the globe use the total revenue test to help manage cash flows. Dell recently faced a dilemma regarding its pricing strategy for computers. Should it increase prices to boost cash flow or adopt a cut price and make it up in volume strategy? So based on a careful analysis of its demand, the company decided to adopt the latter strategy and reduce prices in order to increase revenues, right? So they decided to reduce prices in order to increase revenue. That means that what was their elasticity like? How can we describe the elasticity of demand where they were operating? They were lowering price to increase revenue. Right, it's elastic, right? So we're lowering the price and to increase revenue. That means demand was elastic for them. They were able to identify that, and they were able to realize, okay, so we want to increase our revenues, we need to lower prices versus the other way around if it was inelastic demand, right? So to see why, suppose the research department of a computer company estimates that the own price elasticity of demand for a particular desktop computer is negative 1.7, right? So demand is elastic. If the company cuts its prices by 5%, the question is, will computer sales increase enough to increase overall revenues? So we can answer the question by setting our elasticity, our basic elasticity formula, the ratio of percent change in quantity demand to percent change in price, equal to the elasticity we're given. We know that the company is cutting prices by 5%, so we can plug that in here. And so plugging in our percent change in the price equals negative 5. We can then solve for the percent change in quantity demanded, via algebra. So this is like a variable that we're solving for, right? So we multiply both sides by negative 5. Then we get the percent change in quantity demanded to be 8.5. So the quantity of computers sold will rise by 8.5% if prices are reduced by 5%. Since the percent increase in quantity demanded is greater than the percent decline in prices, the price cut will raise the firm's sales revenue, which is what the elasticity tells us. That's what the function underlying that relationship is. Like this. Again, it's that the fact that like the percent change in the quantity demanded is greater than the percent change in price. And that is what causes revenues to increase as the prices decrease over the elastic range of demand. All right, so that's not the end of the story with respect to elasticity and demand. So although elasticity can vary along a demand curve, overall demand can either be elastic or inelastic or somewhere in between. So if you think about the like, let's say something that's generic that's being sold, like generic aspirin, in that case, that kind of aspirin exists in a market where there's like a ton of other aspirin sellers, right? Just everybody's selling their version of aspirin. Aspirin is super cheap. No seller can really try to make any more than what the market is allowing them to. If they try to change the price, nobody's going to buy from them because there's a million substitutes. And so in a case like this, we say we have perfectly elastic demand, and it can be represented by a flat horizontal demand curve. So the steepness of the demand curve also tells us about how elastic demand is. Even though it will vary along the line, the steepness of the line itself will also give us an indication of how elastic demand is. So a small increase in price in this case may induce their customers to stop buying their product in favor of a competing generic version. The opposite case is when demand is, so in this case we say demand is perfectly elastic. And so this is the extreme case of how elastic demand can be. It can be perfectly elastic, and it can be represented as a horizontal demand curve, versus a situation where demand is inelastic as it can be. In fact, it's perfectly inelastic, and that can be represented by a vertical demand curve. So in this case, you have a situation where the quantity demanded is completely not sensitive to changes in price. So if you think of like life-saving medicine, so many perceive products and services in the healthcare industry, such as life-saving drugs, as having demand curves that are perfectly inelastic. People that need that very specific cancer medication or whatever, will pay whatever they have to for it because it's what's keeping them alive, right? So demand is perfectly inelastic. It is not responsive at all to changes in price under that case. So obviously most cases will be somewhere in between this. So this is just meant to help you remember that the steeper the demand gets, the more inelastic it gets, right? So the closer it gets to being vertical, the more inelastic it gets, versus the flatter it gets, the more elastic it gets. And just an easy way to remember that is like the vertical demand, which is perfectly inelastic, kind of looks like an I, which is the first letter of inelastic. So mnemonic device might kind of help you. All right, anyway. So that's the relationship between demand and elasticity. So let's talk about what can affect the own price elasticity. What can affect how sensitive demand is to changes in prices in any particular market for a good or service. So there are three factors that affect the magnitude of the own price elasticity of a good. The first is, as I mentioned, the availability of substitutes. How many other goods can people buy that will do the same thing your good is doing? The more of those there are, the more sensitive people are going to be to price changes of your good, right? But if there aren't many, like with the life-saving medication, then people won't be very sensitive to changes in price. So demand tends to be more elastic as there are more available substitutes. So one key determinant of the elasticity of demand for a good is the number of close substitutes for that good. A key implication of the effect of the number of close substitutes on the elasticity of demand is that the demand for a broadly defined commodity tends to be more inelastic than the demand for specific commodities. So if you think about transportation in general, people need transportation to get from wherever to wherever, generally their jobs, school, whatever. So the own price elasticity of demand ain't going to be that great, as we see here. So demand will be inelastic for transportation, but different types of transportation will have more elastic demand. So motor vehicles, fairly elastic, 1.4 there. Motorcycles and bicycles, even more so, 2.3 there. So it depends on the amount of substitutes, right? So motorcycles and bicycles, very elastic because there's a bunch of substitutes for motorcycles and bicycles. Walking, buses, whatever. Motor vehicles, people get comfortable, like with the comfort of riding their own vehicles, right? So it's a little bit less responsive to changes in price than something simple like motorcycles and bicycles, but still definitely responsive because there are certainly a good amount of substitutes for motor vehicles. But transportation itself, there aren't really many substitutes for that. One substitute could be like you just don't go anywhere, right? Which is not very realistic. So transportation is inelastic, but the modes of transportation are elastic. Food, again, a general commodity category, inelastic, but cereal, elastic. Clothing, inelastic, but women's clothing, elastic. So market studies do support the statement that demand is more elastic when there are more close substitutes for a product. All right, the second factor that affects elasticity, own price elasticity of demand, is time. How much time do people have to search out alternatives? So demand tends to be more inelastic in the short term than in the long term. The more time consumers have to react to price changes, the more elastic the demand for the good. So here we have transportation. Initially, in the short term, the own price elasticity of demand is inelastic, but in the long term, own price elasticity of demand becomes elastic. So let's say you are traveling to school and work via the bus, all of a sudden they quadruple their prices. You're still going to keep using the transportation. But over time, you're probably going to move closer to your job or your school or wherever in order to save yourself the transportation cost. So demand for transportation will become more elastic in the long run versus the short run. Same thing for food. Initially, we are very, obviously, we're very dependent on food. And so changes to price in food will obviously not be very responsive as far as like how much we're willing to demand of that food. But in the long run, we're going to come up with alternatives. Maybe we won't eat as much, right? Maybe we'll exercise more or just come up with different alternatives that can help us save money on food in general versus, in the short run, maybe just having to deal with price changes, not having many alternatives. So time is a huge factor. So again, availability of substitutes and time. And finally, the third factor is the expenditure share of the good that is in consideration. How much of your overall budget is a good? Is it a small part of your budget, like salt? Salt is cheap. If the price of salt doubled tomorrow, you'd probably still buy the same amount of salt because it's super cheap. So you'll pay a little bit more. You'll still buy the same amount of salt. Your housing, though, it's a big part of your budget. Your mortgage, your rent, whatever it is you're paying. If that were to double tomorrow, you would quickly try to figure out some alternative to your current living situation. You would not hold back. You would not accept it. You would be very responsive. Your demand is very elastic to changes in your housing, which is a huge part of your overall income, your expenditure. It has a huge expenditure share versus salt that has a huge non-impact. It has a small expenditure. It has a small expenditure share of your overall spending. All right. Anyway. All right, so now let's look at the relationship between marginal revenue and the own price elasticity of demand. So again, in chapter 1, we looked at marginal benefit, marginal cost. Comparing those two is how we in economics answer questions to how much of things should happen. How much should a person consume? Well, they have to look at the marginal benefit of consuming one more slice of pizza versus the marginal cost of consuming one more slice of pizza. How many iPhones should I supply the market? Well, let me look at the marginal benefit of supplying that extra iPhone, which is the extra revenue I gain from selling one more iPhone, which is the marginal revenue, versus the extra cost I incur to produce that extra iPhone, which is my marginal cost. So the marginal revenue is the extra revenue you gain from selling an additional unit. So let's look at the relationship between marginal revenue and the own price elasticity of demand. So again, we learned in chapter 1 that marginal revenue is the change in total revenue due to a change in output. Also, to maximize profits, a firm should produce where marginal revenue equals marginal cost. So here's our demand curve, and this is the corresponding marginal revenue curve. The marginal revenue curve is going to be below the demand curve, and I'll explain why in a second. So the line labeled MR in the figure is the marginal revenue associated with each price output pair on the demand curve. Notice that for a linear demand curve, the marginal revenue curve will lie exactly halfway on the horizontal axis from the demand curve. So the demand curve's horizontal intercept in this case is 6, and the marginal revenue curve's horizontal intercept is equal to 3. It's exactly halfway from the origin that the demand curve is. Furthermore, marginal revenue is less than price. So for 1 unit of this good, if we go up to the demand curve, we see what the price is, but the marginal revenue of that 1 unit, the extra revenue gained by selling that additional unit, is less than the price. All right, so to induce consumers to purchase more of a good, a firm has to lower its price. So this is now going to explain why marginal revenue is less than price. So again, it has to do with the fact that if a firm faces a downward sloping demand curve as they move along it and increase the amount they're going to sell, they have to lower the price of all the ones they were already selling. So when the firm charges the same price for each unit sold, this lower price is received not only on the last unit sold, but also on those units that could have been sold at a higher price had the firm not lowered its price. So just a quick example to be concrete. Suppose consumers purchase, let's say, 1 unit of output at a price of $5. So at a price of $5, they purchase 1 unit. So the revenue is going to equal price times quantity. So 1 times 5, which is $5. Now let's say the firm wants to sell 2 units. So consumers will purchase an additional unit of the good only if the price falls, let's say from $5 to $4. So to sell 2 units, the supplier, the firm, needs to lower its price to $4 from $5. So it sells those 2 units. It then will receive $4 in the first unit sold and $4 in the second unit sold. So the revenue will be $4 times the 2 sold, which is $8. But the firm will lose $1 in revenue because the first unit, which would have sold for $5, now needs to sell for $4. And so the marginal revenue, the extra revenue gain from selling that additional unit, is not just the extra price they get to charge for it, but you have to subtract from that extra price the amount you lost from the prior units when you had to lower their price. So marginal revenue is less than price when a firm faces a downward sloping demand curve. Marginal revenue is less than price. So notice again that by decreasing price from $5 to $4, quantity demanded increased from 1 to 2 units, and total revenue increased from $5 to $8. That means the marginal revenue in that situation was the difference between the total revenue selling 2 units and total revenue selling 1 unit, which is equal to $3, right? Marginal revenue, extra revenue gain from selling 1 more unit is equal to $3. All right, now let's go back to our total revenue test. So we know that when prices are high, demand is elastic. By the total revenue test, this means that demand is going to be elastic over the range simply because of the fact that as we lowered our price, our total revenues increased, right? We lowered the price, we know total revenue increased from $5 to $8. So we know demand is elastic based on the total revenue test. In contrast, had the price reduction increased quantity demanded but decreased total revenue, demand would have been inelastic over the range, and we would have been, of course, along this range of demand. Over that range of demand, when as you lower the price, your total revenue decreases, then your marginal revenue, the extra revenue gain from selling additional units, will actually be negative. So that's why along that range, our marginal revenue curve passes the horizontal axis, 0, and starts to become negative. We know that there is a point at which our total revenues are at their maximum, and that happens when we switch over from elastic to inelastic demand, and that corresponds to the point on our total revenue curve where total revenues are at their maximum. Marginal revenue is the slope of the total revenue curve. It is the derivative of the total revenue curve. And so we know from our calculus courses that any curve is at its maximum when the slope of the tangent line, the derivative, is equal to 0. The marginal revenue is the derivative of the total revenue curve, and thus when the total revenues are at their maximum and elasticity is unitary, equal to 1, marginal revenue is equal to 0. Just establishing some connections between all these concepts. All of this is going to be foundations for a lot of what we're going to do in this class. So it's important. I'm not just emphasizing it just to annoy you and just okay, it keeps repeating the same thing in different ways. It's meant to kind of drive it home for you so that you start thinking about the connections, and then eventually you have that foundation so you can understand the later stuff. Anyway, we can establish a mathematical relationship between marginal revenue and price and elasticity. And it will reflect the fact that the more inelastic the demand for the product, the greater the decline in revenue. That results in a price cut despite the increased quantity demanded. So this intuition leads to the following general relationship between marginal revenue and the elasticity of demand. So I'm not going to show you how to derive this, but you should know that relationship. It's a powerful relationship. Once we get into the last part of the course, where I've already highlighted sort of the nature of the approach to maximize profits by looking at marginal revenues and marginal costs of firms, this relationship is then used to be able to estimate some of that stuff without needing to have a department that can estimate cost functions and demand functions and do all the economic analysis you need to be able to take the approach that is taught in this course. You can estimate some of the things you need via this relationship, and we'll talk about that towards the end of the course. But anyway, as far as the relationship between marginal revenue and elasticity, we can plug in some values here and see how the elasticity corresponds to either positive levels of marginal revenue or negative levels of marginal revenue, or a level that's equal to 0 when revenues are at their maximum. So notice that when demand is elastic, meaning that it is greater than 1 in absolute value, then the formula implies that the marginal revenue will be positive, as we know from what we just saw. We know marginal revenue is positive when demand is elastic. When demand is elastic, as you raise price, then total revenues decrease. As you lower price, total revenues increase. So let's say our elasticity is equal negative 1.8. If we plug it into this expression here for elasticity, then you're going to have a negative number down here. You've got 1 plus a bigger negative number than 1. So that means this is going to be negative 0.8 in this case. So you've got a negative over a negative, which equals a positive. So therefore, marginal revenue will be positive when you have demand, own price elasticity of demand being elastic. When the elasticity is equal to 1, it's unitary elastic. If we plug that into our expression here, we get 1 plus negative 1, which is 0. So we have a 0 here, which means the whole thing is equal to 0. Again, at the point where demand is unitary elastic, corresponding to the point where total revenues are at their maximum, marginal revenue is equal to 0. And then finally, when elasticity is inelastic, it's between 0 and 1 in absolute value, marginal revenue will be negative. Again, that is the range over which if you lower prices, then your total revenues decrease, and that means that marginal revenue is negative. And we can check that out by plugging in some inelastic demand into our relationship here between marginal revenue, price, and elasticity. So let's plug in negative 0.8. So you got a negative down here. You've got 1 plus negative 0.8 there. This is going to be positive. Positive over negative is negative. So therefore, marginal revenue is negative. which means that total revenues are decreasing as you are lowering price and increasing quantity. All right, so that's all the connections that need to be established between the elasticity, total revenues, marginal revenue, what you need to know about demand overall as far as like the elasticity related to the slope of the curve, and also the change in elasticity as you move along the curve. All right, now let's talk about this next measure of elasticity, the cross-price elasticity of of this course. All right, so the cross-price elasticity is a measure of the responsiveness of the demand for a good to changes in the price of a related good. It's the percent change in the quantity demanded of one good divided by the percent change in the price of a related good. The elasticity helps managers to ascertain how much its demand will rise or fall due to a change in the price of another firm's product, some related good, right? So again, subscripts are important here. You've got some good X. We're trying to figure out how elastic demand is with respect to the price of a related good. So the cross-price elasticity of demand of good X with respect to good Y's price. All right, whenever the two goods are X and Y, whenever they're related as substitutes, then as we know, the increase in the price of one good will lead to an increase in the quantity demanded of the other good, right? So Pepsi and Coke, if the price of Pepsi goes up, people will substitute away from Coke to Pepsi, quantity demanded of Pepsi goes up, right? If the price of Coke goes up, and vice versa. So they're substitutes. So we know that if this is X is Pepsi and Y is Coke and the price of Pepsi is going up, then the quantity demanded of Pepsi will go up, or Coke, I think I mixed them up. Anyway, you understand what I mean. The point is that these will both be positive, and therefore our cross-price elasticity of demand will also be positive, which again will reflect the fact that the goods are substitutes. And this is something you can measure. Again, just looking at data, we'll learn how to extract that after the break. All right, so again, if this is positive, then the goods are going to be substitutes. So the sign of the cross-price elasticity of demand is going to carry some weight here versus the own price elasticity of demand, which we know will always be negative, and that doesn't really have any information beyond the fact that we understand it to reflect the law of demand. When goods X and Y are complements, they're bought together, right? So peanut butter and jelly. When the price of peanut butter goes up, people buy less peanut butter, but they also buy less jelly because they buy them together generally, right? So those are complements. So when the two goods are complements, an increase in the price of, let's say, peanut butter leads to a decrease in the quantity demanded for jelly, right? So this will be positive, this will be negative. So therefore, the cross-price elasticity of demand will be negative, right? Because, again, they are complements. So either you know that from looking at the number, from looking at the number you already have that you've estimated, or you don't know it, so you estimate it to figure out like what do the market participants in the market I'm interested in view these goods at? Do they view them as complements? Do they view them as substitutes? Well, let me do a regression analysis to figure out the sign of the elasticity, and that will give me the information I need. That will be different depending on, different markets. Like different folks may view different goods as either complements or substitutes depending on cultural preferences, overall taste, who knows? So this kind of analysis can give you a lot of information about what people are thinking about your product. So the cross-price elasticity of demand will be negative whenever X and Y are complements. All right. Which are complements and which are substitutes here? First one is what? They're complements, right? Transportation and recreation are viewed as complements because this is negative, right? As the price of one goes up, the quantity demanded of the other one goes down, meaning people are buying them together. Food and recreation are what? Substitutes. As the price of one goes up, the quantity demanded of the other goes up. People are substituting away from one to the other as the price is changing. And then obviously these are complements as well. So clothing and food have a cross-price elasticity of negative 0.18. So they're thought of as complements. I guess you can maybe, the logic behind that, you can think, oh, well, people, when they want to go out to dinner or whatever, they buy clothes to go out to dinner, fancy restaurants, whatever. I don't know. That link exists there. People view them as complements, at least in the market that they extracted this measure from. So this means that if the price of food increases by 10%, the demand for clothing will decrease by 1.8%. Food and clothing are thus complements. Cross-price elasticities play an important role in the pricing decisions of firms that sell multiple products. Many fast food restaurants offer hamburgers for under $1 because their managers realize that hamburgers and sodas are complements. They're sold together. So by lowering the price of burgers, a restaurant affects its revenues from both the burger and the soda sales. So we can actually look at how that might actually be quantified via a mathematical relationship that incorporates these elasticities and these revenues. So the precise impact on these revenues depends on the own price elasticity and the cross-price elasticities of demand. Generally, suppose a firm's revenues are derived from the sale of two products, X and Y. So the revenue is equal to the revenue gained from good X and good Y. That's what the RX and the RY represent. So the impact of a small percent change in the price of product X on the total revenues of the firm is given by this relationship here, which I expect you to memorize. I'm kidding. I don't expect you to memorize this. But it's a powerful relationship that you should understand, so we'll go through an example. So again, here we're going to have the revenue from good X. Then we've got the own price elasticity of good X with respect to its own price. Here we've got the revenue of Y, and then we've got the cross price elasticity of demand of good Y with respect to changes in the price of X. That is being multiplied by the change in the percent change in the price of X. So the price of X is being changed, and the question is, how will overall revenues change given that the two goods are related? This relationship will tell us. So let's go through an example. Suppose a restaurant earns $4,000 per week in revenues from hamburger sales. Hamburgers are product X. And $2,000 per week from soda sales. Sodas are product Y. All right, so revenue from X, 4,000. Revenue from Y, 2,000. If the own price elasticity of demand for burgers is negative 1.5, which means demand is what? How do we describe that? Demand is elastic. Demand is elastic, right? Greater than 1 in absolute value. And the cross-price elasticity of demand between sodas and hamburgers is equal to negative 4.0, which means that soda and hamburgers are what? How are they related? They're complements, right? As the price of one goes up, the quantity demanded of the other goes down as well as its own, right? So that tells us that they're complements, and it tells us that we have a very elastic demand. So as the price of one changes, the quantity demand of the other drops significantly. So the question is, what would happen to the firm's total revenues if it reduced the price of hamburgers by 1%? So the change in price is negative 0.01. So here is our lovely expression that you're going to get tattooed on your arm after class because you love this equation so much. All right, so here's the equation, and we just need to plug some stuff in and make sure the math is done correctly. So plugging in the revenue, X is 4,000. We have 1 plus the own price elasticity of demand, which is equal to negative 1.5. So you have 1 minus 1.5 there, plus the revenue from selling sodas, which is 2,000, times the cross price elasticity of sodas with respect to the price of hamburgers, which is equal to negative 0.4. And then all this is going to be multiplied by the change in the price, which is equal to negative 0.01. Remember, something like this, order of operations is super important. Please excuse my dear Aunt Sally. So parentheses first. Excuse, exponents aren't there. My multiplication, so we'll multiply this once we're done with it here. Dear, no division, and add together, right? And all this is inside parentheses, so we do all that first, and then we multiply by this. Anyway, so 4,000 times 1 minus 1.5 there, minus 2,000 times negative 4, which is negative 8,000. Then 4,000 times negative 0.5 is equal to negative 2,000 minus 8,000, which is negative 10,000 times negative 0.01 there. And then the answer is going to be $100. So the price of the price of hamburgers has gone down by 0.01%, right? And because of that, overall revenues for this market, for this seller of both hamburgers and sodas, has gone up by $100. And they can tell that based on the information they gleaned from this equation here. So I wouldn't expect you to memorize this, but I would expect you to be able to plug information into it and solve for it and figure out what it means, right? So that's something that could potentially happen. And that's also something that could not potentially happen because we cover a lot of stuff here and I can't test you on all of it. So just keep that in mind. All right. And finally, before we take our break, let's look at the third elasticity measure, the income elasticity. So how sensitive are changes in quantity demand to changes in income? So a measure of the responsiveness of the demand for a good to changes in consumer income is income elasticity. It's the percent change in quantity demand divided by the percent change in income. So standard expression for elasticity there, M, again, representing income. When good X is normal, right, so incomes go up, people buy more of it, that leads to an increase in the consumption of X, which means that our income elasticity will be what? Either positive or negative if the good is normal. Positive, right? They're both going to move in the same direction. Income goes up, quantity demand goes up, income goes down, quantity demand goes down. So the income elasticity of demand will be positive when X is a normal good, and it will be negative when it is an inferior good, right? Inferior goods, again, inferior doesn't mean something is inherently inferior. It's a subjective term. You may consider something inferior, meaning that as your income goes up, you buy less of it. So you think of it as an inferior good. Generally, though, we can agree on certain things like crappy frozen foods, right? Frozen dinners that you can buy at like 99-cent store. Like, you're going to buy less of those as your income goes up. You're not going to buy more of those. That would be silly. So it's an inferior good in general. So that's basically an inferior good once again. So again, as incomes go up, quantity demand goes down. So that would be negative. This will be positive. So they'll always move in opposite directions. So therefore, the income elasticity will always be negative when X is an inferior good. And again, you can do statistical analysis of a market to figure out, well, how do the participants in the market view my good? Do they view it as a normal good or an inferior good? I know that the government's going to raise wages soon. So how is that going to affect my market? Well, let me do an analysis and we look at the income elasticity, and that'll give me the information I need. All right, so this table presents some classic estimates of income elasticities for various products. So is transportation a normal good or inferior good? Normal good, right? As incomes go up, people buy more of it. It's going to be positive. But we can see that ground beef non-fed, so like crappy ground beef, essentially the worst you could possibly find, is an inferior good, right? Just based on the fact that the income elasticity is negative. So again, the income elasticity for transportation gives us two important pieces of information about the relation between income and the demand for transportation. First, since it's positive, we know that consumers increase the amount they spend on transportation when their incomes rise. Transportation is a normal good. Since the income elasticity for transportation is greater than 1, we also know that expenditures on transportation grow more rapidly than income. So if income goes up by $1, people spend $1.80 more on transportation. Makes sense. Like as people's incomes go up, they tend to, stop using like buses and public transportation, actually buy their own transportation, spend money on gasoline, whatever, to be more comfortable so they can not have to deal with the smelly homeless guy who's always talking to himself. Who's probably really cool, but you don't always want to deal with that person. Sometimes you just want to go home. All right, so the second row of our table reveals that food also is a normal good, since the income elasticity of food is equal to 0.8, right? So that's positive, so we know food is considered a normal good. Since it's less than 1, though, we know that an increase in income will increase the expenditure on food by a lower percentage than the percent increase in income, which makes sense because generally, like, we will make food a priority for ourselves. Like, even if we're poor, we're going to spend a lot of our money on the best possible food, right? So as our incomes go up, it may increase a bit the quality of the food we buy, the amount maybe, but not by much, because overall, like, we take care of ourselves, at least in that department, regardless of how much money we're making. So when incomes decline, expenditure on food decreases less rapidly than income itself. Makes sense. All right, let's take a break. Let's come back at 8:35. Let's say. Let's come back at 8:35.